Now we talk about, now we are at the stage where we already have our digital file, right? So that's the first step done. Now we want to recreate that file into the 3D printing object, right? So we need a 3D printer, for example, to do this. But in the market, right, there are so many 3D printing technologies as well as brands out there that provide different technologies for different applications, let's so to speak. So I have listed quite a number of famous technologies over here. We have FDM, the fused deposition modeling, direct light processing, DLP. We have the SLA systems, which uses laser, liquid additive manufacturing, which is a different, very new technology that is up and coming. We have the selective laser sinterings for those nylons, laser melting for metal parts as well with powder bed systems, electron beam melting as well, and direct metal laser sintering. So these are all different technologies that are there. There are much more also, but I couldn't fit everything in one slide. So this is just intro to you, that you can tap on the different technologies and each one has its pros and cons. So you need to understand what is your application and which application is suitable for you, right? Which machine is suitable for you, which technology is suitable for you. So today I'm going to run through a couple of very famous technologies, simple to adopt as well, and then explain to you a little bit more on it. So fused deposition modeling, right? That's the first one, FDM. So FDM is, how I like to explain this to my customers is, imagine you take a hot glue, the hot glue guns, you put a glue stick inside, and wherever the part is heated, right, that's where the glue comes out. So you are layering one layer by one layer by one layer where you want the glue to be. Same concept here, but instead of glue, we're putting in plastics. So the plastic goes into the machine and then it prints out layer by layer the object, and you get your 3D printed part, right? So this is FDM printing, fused deposition modeling. So something like this is how it prints. Layer by layer, it goes up. So what is the benefits of this technology? Number one, it's good for prototypes. It's good for models, right? It's easy to use. So even if you're someone who's just starting 3D printing today, you can plug in and you can start to print, no problem. Very simple and easy to use, I think. The disadvantages for this kind of technologies, the surface quality is not great. So if you're in the jewelry business or the dental business, this is something I will not recommend you to use, right? Also, another very common problem with this technology is warping and very bad accuracy sometimes. Warping is when, you know, imagine you have a hot object touching a cold object. It starts to shrink and warp, right? So this is a common problem that we have with this 3D printing, because the head is normally about 200 degrees and the bed is about 90 degrees. So when you hit it, there is some sort of warping that comes into play, which causes not a fully proper print, right? So what I'm going to share with you now is one of the FDM machines, which I believe is one of the best out there, I think, because I have tried a lot of FDM 3D printers, and the one that I really like and the one that I represent also because I believe in this product is the Markforge printers, right? So these printers are using the FDM technology. And the thing about these guys, right, is that they are the world's first company to actually print carbon fiber, Kevlar fiberglass, right? They are using these materials in the 3D printing object. So what does this mean? When I have, remember when I was telling you that 3D printing is just for prototypes and models? With this system, you don't have to print prototypes anymore. You're actually printing end-use parts, right? You're using carbon fiber, Kevlar fiberglass to make it so strong that it can be as strong as aluminum. And when you print it, you can actually use it for a functional part. And this is where it's being used in your jigs, your fixtures, your toolings, anything in your production line where you need to make something. Instead of fabricating with a CNC, you can now 3D print all of this overnight. And that's how it works. So let me show you a short video. There is no sound in this, so it's okay. What I mean. So this is where it's printing with the plastics and it's reinforced with carbon fiber, for example, or Kevlar. So this part that was 3D printed on the desktop, it's actually holding about 21 to 22,000 pounds, right? And that's about 10,000, 11,000 kgs, equivalent of lifting a car, a boat, a cement truck. So with this force, it actually, it finally broke at 11,000 kgs, about 11 tons of it. And that's the difference with the normal FDM machines that we see and these guys. So these guys are leveraging on the composites point of view. So some of the applications of Markforge 3D printed parts, basically everything and anywhere, right? Because if you can 3D printing something so strong, you can use it for your production toolings and fixtures, your end use parts, your functional prototyping, drones, automotive and performance parts, as well as your prosthetics and orthotics. We have actually have customers in all of these industries, and they're all from Singapore also. And it's amazing how they are using this technology for their day-to-day production use. One example is that one of the hospitals needed to print a prosthetic, and we actually printed the whole cast for the leg. Drones and aerospace, we have a lot of drone companies who are using our materials and leveraging on Kevlar, for example, because it's good absorption of impact for their drones, right? So this is where 3D printing can come in and make an immediate impact, where you print it overnight, straight away use it the next day. Yeah. Now, what you saw earlier on was the FDM process, but one thing that a lot of people feel is that the parts that we 3D print nowadays, if you look around, it's actually very small, right? We only can print maybe up to 30 cm by 30 cm, and that's all we can go. But why must it stop there? That's why I chose, and I studied, and I looked around, and I found out about Big Wrap, right? So Big Wrap is a 1 meter by 1 meter 3D printer, right? So now you can print no longer scale parts, you can print huge parts, 1:1 scale for your use. And there are so many applications for this, especially in the signage industries, the props factories, the propeller industries, sand casting, molding, which I'll explain to you shortly. So take a look at this.
Every big idea starts with a question, a problem that needs to be solved, a passion to invent something new. We believe that through innovation and creativity, big ideas come to life. Introducing the Big Rep 1, a revolution in large-scale 3D printing. The One's award-winning design is rooted in uncompromising German engineering. Built with a capacity of over 1 cubic meter, the Big Rep 1 has the largest FDM build volume on the market. With the Big Rep 1, there's no need to scale down your original designs. Print objects quickly, reliably, and consistently. The open build design ensures that the user has the best possible view for monitoring quality from all angles. The 2 modular print heads allow for top flexibility when printing in 2 colors or with support materials. Their independent movement ensures a clean print result while changing between filaments. The print heads can be equipped with either 0.5, 1, or 2 millimeter nozzles. The 2 millimeter nozzle slashes build time. Whether you're producing a series of objects or designing a single product, large-scale prints now build faster. An integrated control unit and touch panel allow you to monitor print time, change the speed, or even adjust the temperature of the print bed, all while the print is in progress. Ideate, design, print. Here at Big Rep, we're making big ideas a reality for everyone. What is your next big idea?
So